This is the new Unit 6 for Algebra 2. We're going to start with our first lesson today, 6.1, which is all about inverse functions. If the function is a set of ordered pairs, x, y, then the inverse of the function is a set of ordered pairs, y, x. Notice all you did was switch the x and the y. So for example number 1, you have a list of ordered pairs. You're going to take the 3, 7 and change it to 7, 3. 4, 12 becomes 12, 4. Negative 3, 2. 2, negative 3. Notice we didn't switch any signs there. The negative stayed on the 3. And then 5, 8 becomes 8, 5. Same thing with example number 2. Negative 1, 6. Switch their locations. Becomes 6, negative 1. Negative 2, 4. 4, negative 2. The third point, 4, negative 3, becomes negative 3, 4. And the last point, 5, negative 8, becomes negative 8, 5. For the next part, we're going to graph these. Notice that you have something that's already been graphed, and we're just going to graph the inverse. So you're going to take each of the points that's labeled, for example, 6, 8, and you're going to switch it to yx, so 8, 6. And then you would plot the point 8, 6. So from the center, the origin, you would go to the right 8 and up 6. And that's the point 8, 6. Next one is 1, 4, which we'll change to 4, 1. Plot over 4, up 1. Negative 2, 3 becomes 3, negative 2. Go over 3 and down 2 to plot 3, negative 2. Negative 4, negative 1 becomes negative 1, negative 4. Left 1 and down 4. And then our final point, negative 5, negative 4, becomes negative 4, negative 5, just switching the x with the y. So I'll go to the left 4 and down 5 to plot. And then because the dots on the original graph are connected, I'm going to go ahead and connect mine here. And that would be the inverse. Notice it's a direct reflection over the line y equals x. That's why that's drawn there, so you can see that it's a direct reflection. All right, take a second here and go ahead and try example 2 on the graph. Right. I'm going to make a list of the points that I'm going to plot. 3, 6, 2, 3, 1, 0, 0, negative 3, and negative 1, negative 6. And we'll just go ahead and plot each of those. Over 3, up 6. And if you don't want to draw them, write the points on the graph, that's okay too. Over 2, up 3. Over 1, up and down 0. Right and left 0, but down 3. And then left 1 and down 6. And again, because the original graph was connected, we'll go ahead and connect those points right there. Now you have the inverse. All right, now what about a graph that isn't drawn for you? Let's look at example number 3. So we're going to need to draw the graph originally, and then we'll talk about the inverse. So in order to do this, we're going to need to make a little t-chart. with our x and our y. And f of x is the same as the letter y. So you could almost think about this equation as y equals 2 to the x power. I'm going to choose some numbers that are going to be easy for me to plug into exponents. I also want to make sure I get a negative number in there. So I'm going to start with -1 and then go my basic numbers 0, 1, 2. Maybe we'll go up to 3 this time. And so what I'm going to do next is I'm just going to use my calculator to help me plug in these numbers. So for the first one, -1, I'm going to do 2 to the exponent, which is this button right here, to the exponent of -1. When you type in a negative, please make sure to use the negative button, not the minus sign. So -1, and hit enter. That's going to get you an answer of 0.5. Now we'll do 2 to the exponent of 0, which is 1. 2 to the exponent of 1. You could probably do some of these in your head. That's fine. That'll get us an answer of 2. 2 to the second power. 2 squared, I know, is 4. And 2 to the exponent of 3. And if you don't have a calculator with you that has exponents, you could always do 2 times 2 times 2 to get that 8. All right, so we'll go ahead and plot those points. -1.5 would land right about there, right in between the 0 and the 1 line. 0, 1 will be right here. The point 1, 2 over 1 up 2. 2, 4 over 2 up 4. And 3, 8 over 3 up 8. There we go. So this looks like it's kind of curving. The graph is going to look like this. Kind of curves up like that. We call that an exponential graph. All right, now let's answer these questions. What are some of the points on the graph, the x, y? So I'm just going to write a couple of these down. I've got -1, 0.5. I've got 0, 1, 1, 2, 2, 4. May as well write them all down, and 3, 8. So then in order to find the inverse, you would just write the ordered pairs as y-x's. So just like we did on examples 1 and 2 at the very top, we're just going to switch these around. So 0.5, -1. Switch 0, 1 to be 1, 0. Switch the x and y. Switch the x and y. Switch the x and y. And then let's graph these just to see what it would look like. 0.5, -1 would be right there. 1, 0 would be here. 2, 1. 4, 2. And 8, 3. So you can see, just like the graphs above, it looks like a mirror image, a reflection, one graph to the other. All right, for the next part, we are going to do this algebraically. So you've got 2 steps. We're going to start by switching the x and y variables in the corresponding equation. Then we will solve the new equation for the y variable. In other words, get y by itself. Now, a couple things to mention. F of x is the same as the letter y. We talked about on the front page. F of x is y. And anytime you see f to the -1, that means inverse. F to the -1 is inverse. Find the inverse of the following functions. So example number 1, f of x equals 9 minus 2x. Find f to the negative 1 of x. So remember, this means inverse. So all this problem is asking us to do is find the inverse. We'll start by taking our f of x and rewriting that as the letter y. We're more comfortable with x's and y's. So we're going to write these all as y equals. Then you're going to do step 1, switch the x and y. So you're going to have x equals 9 minus 2y. The x and the y switched places. Notice how none of the numbers moved, just the x and y. From there, you solve. So we'll try to get the y by itself. I'm going to subtract 9. X minus 9 equals negative 2y. To get the y by itself, you would divide by negative 2. The negatives cancel and the 2's cancel. And then over here on the left-hand side, I'm just going to go ahead and leave that final answer. So I'm going to write my answer as y equals, I like to write y equals in front, x minus 9 to the negative 2 over negative 2. You might also see the answer written as f to the negative 1 of x. Remember, that means inverse equals our answer. Might also see that sometimes. All right, let's look at the next one, example number 2. F of x equals x minus 4 all to the third power. Find the inverse. So we'll start by switching this out for the letter y. And then I'll change my x and y. To get rid of an exponent of 3, we're going to cube root both sides. So when we cube root, we will take the third root and the third root. You want that to match that, and then those cancel. The third root of x, I can't do anything with. There's nothing to simplify. So I just bring it down, and then I bring down the y minus 4. Last step, add 4 to both sides. Third root of x plus 4 equals y. Or you can write it as y equals the third root of x plus 4. Either one of those is good. You could even write f to the negative 1 of x. Inverse is the third root of x plus 4. All of those are great answers. 1, 2, 3, all great answers. As long as the y is by itself, you know you've solved. All right, example number 3, we'll start by changing the f of x to a y and switch the x and y. We need to get rid of the 5. The 5 right now is being divided, so we're going to multiply both sides by 5. 5x equals y plus 6. And then you could subtract 6 from both sides. 5x minus 6 equals y. Or you could write your answer as y equals 5x minus 6, or even as f to the negative 1 equals 5x minus 6. All right, example number 4. Start by switching that to the letter y. Switch the x and y. I want to get rid of that 3 in front, so I'm going to start by dividing both sides by 3. X divided by 3 equals y plus 2. If you know the very last step, go ahead and try it. The last step is to subtract 2 from both sides. Now this x over 3 is a division problem, so you're not actually going to be able to combine the 2 with anything. You'll just be able to bring it down. As long as y is by itself, you can stop working the problem. All right, example 5. Switch this to a y, then change it to x. Change the x to y. And then think about what the opposite of a square root is. Up on example 2 on the back side, remember we put a third root right here. We put a third root to get rid of the 3. So third roots, square roots, fourth roots, all of those have the opposite operation. You just have to have the exponents match there. So the square root is the opposite of squaring. That and that will cancel. This leaves x squared equals y minus 4, and add 4 to both sides. X squared plus 4 equals y. Again, several ways to write it. You could write the y equals first, or you can write even f to the negative 1 of x equals x squared plus 4. Remember, that right there just means the inverse, which is what we're trying to find anyway. All right, our very last problem, example number 6. Start by switching that to a y. Switch your x and your y. Divide by 3. You get y to the 1/4. Y to the 1/4 is the same as writing it as the fourth root of y. And we don't need that invisible 1. Remember, up here would be an invisible 1, but we just don't need it. So I'm going to leave it off. And to get rid of the fourth root, you raise it to the 4th power. Those cancel, and you're left with y by itself. Now over here on the left, x over 3 to the 4th power, we're just going to go ahead and leave it, equals y.